Hi, I'm Sweta from Harmony Schools and I did my PBL project about the fractal geometry in our lungs. This is the model I created of how our lungs look like from the inside. I used one piece of paper, one pencil, one Sharpie, 1 meter long string, a pair of scissors, a roll of tape, and ruler. First, draw a straight line with the ruler in the center of the paper and make sure it's 7.5 centimeters long. Then draw another straight line starting from one end of the first line and create an angle that measures about 45 degrees. Do the same thing from the non-touching ends of the two lines drawn. This time, draw the lines half the length of the previously drawn lines, so it can be 3.75 centimeters. Repeat these steps a couple of times. Once you're done, this is how your model will look like. Now trace your model with a Sharpie. Begin to cut the string so that it traces the model. Begin taping the string onto the model as shown. Continue to do the same thing until the entire model is covered. However, you do not have to do the small parts because it's difficult. Once you're done with that, you're ready to go with your model. First of all, I'd like to talk about what fractal geometry is. Fractal geometry is a study of geometric patterns getting smaller as it repeats forever. It can be identified in many things like the leaves of a plant and the clouds in the sky. You can find fractal geometry in arts, mathematics, science, and technology. It's not only in these fields of study but can also be found in our body. In this investigation, I found the relationship of fractal geometry within our lungs and how it affects our body in what ways. Now, the reason why there are fractals inside the lung is because the task of fractals is to maximize the amount of space given, and since our lungs need as much space as possible in order for the oxygen to flow and keep us living, fractals play an important role in making this happen. If the lungs did not have a fractal pattern, then it would have been much more difficult to breathe and for the lung to function, since the fractals make it much easier and quicker to flow oxygen in and out of the body. The human body would most likely not be able to function properly if our lungs did not have a fractal pattern. You can find fractal geometry in arts, mathematics, science, and technology. It's not only in these fields of studies, but can also be found in our body. Fractal geometry can be studied in all types of body structures and several diseases as well. It can be used to study skin and lung cancer, cellular movement, blood vessels, cellular growth, viral growth, bacterial growth, and so on. Fractal geometry is everywhere. It can be used to study the tiniest electrons to our entire Milky Way galaxy. Fractal geometry resembles the connection between mathematics and the rest of the universe. The history of fractals started all the way back in the 17th century when the mathematics in fractal geometry first began to take shape. It began with the early mathematicians Gottfried Leibniz and Karl Weierstrass. After the 17th and 18th centuries, more mathematicians became interested in fractals. Helge von Koch came up with his Koch curve, and later Wacław Sierpiński built his famous triangle and carpet. The mathematician to solidify all the studies of the early centuries, however, became to be Benoit Mandelbrot in the 1960s. He found the exact definition of fractals and also created computer-constructed visuals of fractal geometry called the Mandelbrot set. In conclusion, we can see that fractal geometry plays a major role in our lungs. If we did not have the fractal pattern inside our lungs, we would most likely not be able to function. This shows us that fractal geometry can be anywhere in nature and that it's always going to have a purpose for being there. Thank you for watching Harmony Schools.